Okay, example number 26, okay? It is a little bit complicated, but I believe you can do it, okay? And as long as your like Laplace transform table on your side, and you can do it, okay? Let me show you how we can take care of this one step by step, okay? First of all, e to the minus s, it is concerned with your unit step function. So we're gonna write this one on the side, okay? E to the minus s times s minus 2 over s squared minus 4s3. Oh, look at your denominator. Okay? It is like possible to do factoring, right? So this one can be written by e to the minus s times s minus 2 over s minus 1, s minus 3, right? So it is really tempting to do partial fraction, okay? My son is here again. He just want to play with me. Okay? James, can you please just one thing? Okay. Okay. So partial fraction. Okay. There we go. This will be written like this way: a over s minus 1 and b over s minus 3. Okay. When you do this partial fraction, you can easily find your a and b value. Let me give it to you. Okay. E to the minus s times 1/2 s minus 1 plus 1/2 s minus 3. Okay, are you doing so far? So let me split this one. Okay, like that's it. Okay, so now let me try to find your inverse Laplace transform. Okay, your GT is equal to inverse Laplace transform of G of S. Okay, so like by linearity property, we can write like this way: 1/2 inverse Laplace transform of e to the minus s times 1 over s minus 1 and plus 1/2 inverse Laplace transform minus s times 1 over s minus 3. Okay, I'm sorry about that. Okay, here we go. Then now keep that in mind. In the table, it was noted by UTG t minus 1. Okay, with, let's say this is G1s and this guy is G2s. Okay, then by number 13, it is equal to 1/2 unit step function with 1, and we need G1 of t minus 1 because I get 1 unit shifted plus 1/2 U1 t and G2 of t minus 1 as well. And now we have to figure out like G1 and G2, right? I can't let you know.
아빠 다 먹었어.
좀 비벼.
It's okay. 아빠 우리 다 먹었다. 맞아, 우리 다 먹었어. 미안해. 빨리 가자. 야, 가자. 손소가 만지래.
Okay, which is equal to inverse Laplace transform. I'm sorry about like I'm chewing something because my daughter and son loves me a lot. That's why. We know about this, right? It's in the table number 2, right? It is equal to e to t, right? And what about second one? Equal to inverse Laplace transform of 1 over same thing. That's it. That's it. Okay. Now, there we go. That is equal to 1/2 u1t e to the not this one, but like you're plugging t minus 1 instead. Okay, like that, and plus 1/2 u1t, and for this one we're gonna plug in t minus 1 here, e to the 3 t minus 1. It's okay. That's okay. But actually, this is correct answer. Okay, but and we know about hyper cosine, right? So like if you do like this way, uh, you want the out, and if I take 2t minus 1 out, then it will be e to the minus t minus 1 and plus e to the t minus 1. And do you remember this guy? That is hypercosine differential, okay? Is equal to u1t and cosine hypercosine of t minus, okay? Much simpler way, okay? But I don't know if this is a simpler way for you or not, but like, don't worry about it. Like, we don't have to worry about this way. Then as long as you can find this way, it is perfect. Thank you.